Good night, yours truly, Professor Dr. Dolphy Gilpin. As we continue with our random selection, elements from the periodic table, tonight we're focusing on Promethium, atomic number 61. And this is a partial view of it in the lanthanide series, symbol PM. Atomic number 61, and adjacent to it would be samarium. We'll also take a look at samarium, atomic number 62, and atomic mass of 150.86. And if we have time, we'll take a look at another. But for now, it's Promethium. Also, we refocus on uranium. Or rather, I will refocus on uranium to bring upgrades. And a course I did a long time ago, Nuclear Power Engineering, EE 455. Uranium and plutonium and fission and all of that. But right now we are on samarium, atomic number 61. Or rather, Promethium. So we are with Promethium. We go to our elements of the periodic table in a cardinal fashion. We try to extract Promethium. PM. We're trying to separate PM, Promethium, atomic number 61, from our card deck here. We'll also be looking at samarium. So samarium 62, we'll introduce samarium tonight. So let's introduce it from now. Antimony, lithium, oxygen, technetium, californium, gallium, iodine, cesium, selenium, chlorine, copper, cadmium, copper lucid. Calcium, cobalt, carbon, chromium, copper, Rn, that's 222, 86. Which one is that? Radium or radon? Radon. DB, TB, Asium, berkelium, bismuth, nickel, uranium. Uranium will also be focused upon tonight again. Review, nitrogen, borium, TH90, DY66. Let's keep that near. Osmium, krypton, mercury, nitrogen, hydrogen, oxygen, vanadium, TM69, 160.98, 81, tungsten 74, beryllium 102, sulfur 16, zinc 30, potassium 19, silicon 14, wendigium 111, titanium 22, strontium 38 SR. Is it? Alright, let's keep it SR, atomic number 38, MB, molybdenum 42, stadium 110, HO67, and zirconium 40. This is gadolinium, terbium 17. Okay, these are when we're doing that modern IUPAC nomenclature. This one is unyl quad-dium 104. This is phosphorus, lead, PA protactinium, PD palladium, PA protactinium 91. So we haven't found our sulfur. This is plutonium. This will come up whenever we come up with uranium. Other thing, there's a isotope that goes straight from uranium into plutonium by radioactive decay. Polonium and PM. This is one that we wanted. Okay, so we have PM, Promethium. Since we have used up all our time trying to separate it, to focus on it, Promethium here, atomic number 6-1, and atomic mass of 145. Okay, its noble gas configuration or electronic configuration is Xeon 4f56s2. It's a radioactive element, F block, period 6, solid at room temperature 20 degrees centigrade. A group of the lanthanide. It's mostly used in research, and it can be used in atomic batteries. is usually the size of a drawing pen, and are using pacemakers. That means in medicine, Promethium comes in quite useful. Even the pins in pacemakers, also in guided missiles for war, and also in radios. So those are some of the application and uses for Promethium. Atomic number 61, atomic mass 145, and F block, period 6, and let's just sort of revise a fact here that with any of the elements with an even atomic number in the lanthanide series here, you could see that the isotopes or the element itself become less stable. The isotopes would be less stable than, say, for an element with an even number of protons, which is the basis for the atomic number. So we say facts, atomic nuclei with an odd number of protons are less stable than those with an even number of protons. This is a fact that we have seen, characteristic property of the elements of the periodic table. And this is so even if the total number of nucleons is the number of protons plus neutron, are even or odd number elements. And therefore have fewer stable isotopes. Promethium is the only rare earth metal of the lanthanide series of the periodic table not found in nature on Earth. A little more that we're going to step into the reactions, and we'll take a break first. Step into the reaction of Promethium. Atomic number 61, atomic mass 145. So there we have a very medical use for the Promethium would be pacemakers.